Alright, let's go around and let's go in the same order. We're going to do all the threaded holes next. So we needed to use our tap drill size for that. So we're going to go to drill, and we're going to select our for our main library, mill library. We need the tap drill size for the 632 thread. So that was the number 36 stub drill. We're going to select that. Yeah, we're going to slow the RPM down. We'll go 10 inches a minute on that. We'll go back to our selection. We're going to select the entire hole feature, including the chamfer on both sides. Okay, and then what we're going to do is we're going to say auto merge those segments, so it treats it as if it's one hole to be drilled. And we're going to use select all of them that are the same diameter. So we should be receiving, we need to select each face to do so. Okay, so we've got all the hole features that have selected same diameter, and it should be made, each individual location should be merged into one hole. Okay, we're going to go to our heights. We're going to leave everything at default until we get to the from top of hole. We're going to leave that, and we're going to go from bottom of hole, but we want our drill tip to go all the way through, so it's going to poke through a little bit more, and we're going to go a little extra distance because we want to go a little bit deeper than that so that our tap can clear all the way through the part. If our thread is a 30-second per pitch, we'll go 5 30-seconds. Okay, deeper than our thread pitch, and what that'll do is it'll give us at least 5 threads per inch deeper for our tap to clear all the way through. So it's 2 to 3 thread pitches, but we're going to go a little bit farther through because remember we're mounted on top of a plate, so this is going to drill through our subplate, and we're actually going to be tapping the very top of our subplate. So if we go 5 thread pitches plus the tip deeper, when we do our tapping, we'll go 3 pitches deeper, and we'll be assured to have a full thread in our steel plate. Okay, we're going to go to the next tab, and we're doing we're going to do because this is steel, but we're going through aluminum also as our subplate most likely. We're going to go ahead and do a deep drilling. Actually, we're going to do it as a diameter, so 0.107. So we'll get 2 or 3 pecks as we go through the metal into the aluminum. We're not going to do a dwell, and we'll accept that. Okay, so we've drilled sufficiently through our plate. We're going to come back and tap those holes. So we go to drill again. Select from our library our tool number 11, which is our 632 tap. 1000 RPM is a little fast for steel. We'll go slower than that. Let's go 250. Okay, we're going to select same diameter. We're going to auto merge, and we're going to select the chamfer, the hole, and the chamfer on the opposite side. And now we've tapped all 4 of those holes. Okay, we want to go to the next tab. Okay, we're going to leave all of these parameters the same, but we're going to go negative 330 seconds. And that's to make sure that we have a fully formed thread all the way through. So we should have 60 thousandths of clearance with our actual hole drilled through the other side. And we're going to accept that. And we now have all the threaded holes done. Okay, so now we're going to go through and do our 1/8 inch holes that have to be reamed. Okay, so we're going to go and we're going to select our tools for that. So we're going to go another drilling cycle, select our drill, we're going to go to our library, and we're looking for, from the mill library, the drill bit that's slightly smaller than oversized reamer for. So we're going to use this 127 thousandths reamer. So we have a nice slip fit on those holes. And the drill bit we selected for that is 120. So we're going to go ahead and select that. It's 5 thousandths undersize. And for the tolerance, this hole here is 125 plus or minus 5 according to our drawing. We're going to go ahead and drill it intentionally undersized so we can save tools. And we don't need to ream that particular one. Okay. We can save a little bit of time by doing that. This is a wire passage, that one particular hole. Okay. So we got it selected in our library. We're not going to go 5,000. We're going to go 2,000 because we're cutting steel. We're going to skip to the next tab. And for this tool, we want to select the same diameter and auto merge again. And we're going to select the top chamfer, the cylinder, and our bottom chamfer. We go to heights, and we're going from top of hole to hole bottom, but we want it to drill all the way through. And likewise with the tap, the reamer needs a little bit of clearance. So we're going to go a little bit deeper, and we'll go by, let's do one diameter of our tool. So it is 0.12. We're going to go 0.12 deeper. And then over here on our drilling, we're going to do the deep drilling again. And our peck depth, we're going to set that as 0.12, which is a diameter of our drill. We could go half, but we'll do that. And no dwell. Okay, we accept that. Now we're going to ream our holes. Okay, so the reamer is going to come through and do all of the holes except for the one. So we're going to go drilling. We're going to go to the library. We're going to go to our mill library. We're going to select our 127 reamer. Okay, 2,000 RPM is probably too fast for steel. We'll go 1,000. Our feed rate needs to be significantly slower. Go 10 inches a minute on those. Okay, we go to selecting. Okay, so in this case, I'm just going to select the cylinder diameters. And then we come back and select our chamfers. We're going to make sure auto merge is selected. Then we flip it over and do our other side. So we should have the both ends of all the holes except for this one here, which is just, we're leaving it as is. It's going to be a little bit undersized. Okay, so we're going to go to heights. Again, we're going from top of hole to bottom of hole. We don't really have a tip to compensate for. We went 120 thousandths deeper, so we're safe going, let's say 40 thousandths deeper. Remember, on this box you actually have to have a negative symbol, and that way our reamer goes all the way through. Our last tab, it should default to reaming, feed in and feed out, and we'll just leave that at default there and hit accept. Okay, so we've now drilled those, reamed those the size. Now we need to come back and drill our clearance holes here. Okay, so we're going to go to drilling one more time. Actually 2 more times, but And we're going to select from our library our clearance drill hole for, I believe it's a 632 thread. So our clearance drill bit was the number 18 drill, and it happens to be in position number 18. Nice and easy to remember. Okay, and again, we're going to slow the RPM down. Go to 2000. I think the feed rate of 13 inches a minute is probably fine for that one. Okay, and we're going to auto merge hole segments. We're going to select the same diameter. I'm going to start with the chamfer, and then we select the cylinder, and then the countersink, and then we select the countersink on the opposite side as well. Okay, so that merges those 4 holes into one. And then we're going to go to depths, and this one they're just clearance holes. We're not coming back to make any more features on the inside diameter of the hole. So we'll leave all this at default. We'll go from top from hole to bottom of hole. We do want to break through and maybe go 10,000 steeper just to make sure we've gone all the way through. Okay, we're going to accept that. Now we're going to go through and just do the countersinks. Okay, so one last drilling routine. So we're going to go to drill, and we're going to select from our library our countersink 82, which is tool 20. And we're going to go, we're not going to go, well, this is a single flute tool, so we do need to go fairly fast on it. So let's go 4,000 RPM on it. It is steel. And our speed, we're going to go 10 inches a minute. Okay, we're going to go to the next tab. What are we doing? We're going to select the same diameters. We're going to pick the chamfer top, the countersink face. We're going to go to depths, and this one we're going to go, everything is just going to be default settings. If you wanted to ensure you're splitting the tolerance, you could go deeper by half the tolerance here. So you could go 0.005. Okay, so then we're at half our plus or minus 10 tolerance for the diameter of that. It won't be directly proportional because it's 82 degrees instead of 90, but that should at least make sure the screw is flush with the surface as opposed to proud. Okay, and we're going to go to a counter boring cycle, which is going to allow us to put a 2-second dwell at the bottom. Oh, this is a single flute. It'll make sure that it sits there and scrapes away pretty good at its final depth instead of pulling back up and leaving a dwell mark. Okay, we'll accept that. Okay, so we've now completed basically all of program 1. Okay, and so side 1 has its clamp. Now we have to go to the next operation. It is as if it's bolted down. So this is where an operator would have to take action. You can write one program and put what's called an operator stop in. Its code usually on most machines is M00, or if it's an optional stop, it can be M01. But we're going to just split this in 2 different programs to make it discrete. Okay, so we're going to go in, and all we're going to do is profile around the outside of this part. Okay, so we're going to right click on the next operation, and we are going to make it our default folder for now, and we're going to do a 2D milling, 2D contour, and we're going to select from our library. We had one tool that was for cutting steel, and it was our 4-flute 1/4-inch end mill. We're going to select that tool. We're going to slow our RPM down. Let's go to 2000 RPM. Cutting feed rate 13 inches a minute. Our lead in is going to be 13 inches a minute. Our lead out is going to be 13 inches a minute. And likewise on the rest of them. Okay, we're going to select the outside contour of the model. It's going to loop around. And we're going to go from the clearance height is going to be from the retract height. The retract height is going to be stock height. The feed height is going to be from the top. The top is the top of the stock, which it's kind of semantics, the same as the top of the model. And then we're going to cut to the contour. Now I want to cut a little bit past the contour just to make sure we don't have any flash on the part. So I'm going to go -0.01. So we're going to cut 0.010 into our subplate fixture. Okay, we're going to go to the next step and we're going to do wear compensation. We are going to do a rough pass. We're going to do rough passes. Our maximum step over, our finishing step over is going to be 0.05, and our roughing step over, our finished pass step over is going to be 5 thousandths, and our roughing passes are going to be 0.01. So we're going to leave a roughing pass. We're going to do a single pass, leaving 10 thousandths for the finished pass to remove. And we're going to do it in steps. And so we're going to go in 40,000 steps, and we'll do a 5,000 steps finished pass at the bottom. What that's really just going to do is be a spring pass, so if there's any cutter flex. And we're going to finish only at the final depth. So it's going to do steps on the roughs, and then it's going to come back and do the finish step. I want to select even step overs. We're not going to leave any stock to leave. And our smoothing, we'll leave that alone. This is mostly linear moves. The only place smoothing would come into play is when it comes around the corner. Okay, our last tab, we got a lead in at 90 degrees. We're leading in by 25 thousandths. Now we have significantly more material on one edge than the other. So what I would like to do is actually lead in, specify where the lead in is, or lead in and lead out's the same. Now vertical lead in, I'm going to put it at 0. I don't see the point of it in steel. You're just going to break cutters. Okay, but the linear lead in and the radial lead in X and Y is fine. Okay, so we're going to select our entry position, and we're going to select the point on the right here. So if this is our sawn edge direction, it's going to have a minimal amount of material on it. This is also on the side where the operator can see where the cut is starting as it goes around clockwise around the part, as opposed to the plunging being behind the part where the operator can't see it. Okay, we're going to accept that resultant, and it processes, and we should be seeing that we've got 1, 2, 3, 4, 5, 6, 7 rough cuts, and then it steps in and does a finished pass all the way around the plate. Now I'm going in these small increments because the diameter of the cutter we're using is only 1/4 of an inch, and there's a significant amount of flex in steel for a cutter of that diameter. So I don't want to take off too much per height. Okay, that's it. That's done for op 2. Now we're going to do the opposite side. So we're going to right click on that one and make it our default folder, and we'll flip our part over so we're looking at it the same way. Alright, so what we're doing is all we're doing is edge reliefs on the holes. And so we're going to have to do 3 different patterns because they're all different depths. But we're going to be using our spot drill. And in fact, we're going to go to the first drilling routine, and I'm going to right click on that and say copy, and then we're going to go and paste it. Okay, so we've copied the parameters from the other side. Let's edit that routine, and so all our feeds and speeds should be the same. We're going to go to geometry. We're going to delete that face, so we're not drilling from the other side of the part, but we are going to select on the near side that face, and we're going to select all of them that they're the same diameter. And so what we get is the same depth parameters we use on the opposite side. We don't have to re-enter that. So we've got our -75 thousandths for our depth. Okay, and we should be able to just accept the rest at default. Alright, now let's go and do the same thing to this second routine. We're going to right click on that. We're going to say copy. And then we're going to say paste. And we regenerate. We're going to edit that cycle. Again, the first tab, we can take everything that's there. We're going to delete our faces that we selected. Now we're going to select the 1/8 inch holes, the face of the chamfer there. And we're going to select all same diameters. Okay, so it's going to go through and do all those. We can leave this all at the same depth, 108 or 85 thousandths, and we're drilling and rapiding out. Okay, so now we just have one more routine. Let's go ahead and we're going to duplicate the drilling cycle we just used. Right click on it, edit. We're going to keep the same settings on the first tab. On the second tab, we're going to delete the face that we have selected. And then we're going to select the larger diameter. We're going to select all of them if they're the same size. We're going to go to our next tab. And we need to put in a different value for this depth of hole. So if we go to evaluate, measure, and we measure the diameter of our countersink, it's 210 thousandths. So we need to go negative 210 divided by 2. And that gives us, I'm sorry, it's not negative 105 inches, it's 150 thousandths. Okay. And so that gives us the depth for those holes. And the rest of the tabs we can take at default.